Now this module A lab, we will try out Azure Firewall. Now with Azure Firewall, the goal is the firewall becomes the next hop for all the exiting traffic within the virtual network. So suppose that we have a VNet. Now Azure Firewall has to reside in a dedicated firewall subnet. So this being a firewall subnet. We'll be deploying a workload subnet. Okay. Now, under normal condition, workstation deployed into a subnet has direct access outbound to the internet, okay, and be able to pretty much do any communication against the internet host on its own. Alright, so let's say we make this more interesting by deploying a few additional subnet. Controlling traffic between these subnets using exclusively NSG or ASG, the things we talked about in Lab 7, gets very complicated very quick. Okay, namely because the NSG and ASG applies to the NIC and to the subnet. So if I have 4 separate subnets, it's going to be very difficult if each subnet is allowed to communicate directly to another subnet and still apply NSG to control the traffic. It gets very messy very quickly. Okay, so for example, in order to control machine D, I would need to create rules when it head out to C, head out to B, head out to A. So there'll be 3 rules and it becomes very difficult to manage. A better approach is that we can direct traffic so it always lands on that firewall appliance first. Now this firewall appliance will be able to apply rules against web traffic, TCP/IP traffic, and then we can use a web-based management tool within Azure Portal to manage the rules. So what's left for us to do is to deploy the workload and make sure the workload does not try to go out onto the internet on their own. We want to make sure all these machines, when they send traffic outside of the subnet, a routing table will pass the traffic to the firewall and let those rules decide whether or not the traffic should flow. So that way we don't have to define rules within each subnet, within each NIC. So it's much more manageable. And when you have separate subnets and different isolated networks, Azure Firewall makes life a lot easier. Now, of course, there are many firewall vendors out there that can give you a virtual machine based firewall. Now, none would be as polished and as integrated to the Azure portal as the one we're about to introduce to you. Alright, so let's do it. Alright, so here's the outline of what we will do. We'll use our ARM templates to deploy the virtual network. Get an Azure Firewall. This will take some time. Create the rules, default route, user-defined routes. Okay. To make sure workload always send the traffic to the firewall as soon as the traffic leaves the subnet. Alright, I'm going to set up application rule, network rule, and make sure that it actually works as described. Okay, so we're going to start by deploying a custom template. Now in the labs 08, there should be a template file. We're going to deploy this against a new resource group. Alright, when the deployment succeeded, navigate to the virtual network. The virtual network we deploy through the template is called testfwvn. You can go down to the monitoring section and click on the diagram to see that there are 3 subnets. Okay. 1 VM in the workload, 1 VM in a jump. We have an empty subnet. That empty subnet has to be called Azure Firewall subnet for you to deploy an Azure Firewall into it. Okay, so it has to be one of those hard-coded names, just like Gateway subnet. Alright, so let's go ahead and deploy an Azure Firewall appliance. Alright, so on the search, I'm searching for Azure Firewall, the first one that comes back. And you'll see other vendors' firewall as well. So I'm going to select Azure Firewall, create. Alright, so that's a firewall name. We already have a virtual network. We want to make sure we add a new public IP. We don't want to use the public IP that was assigned to another VM. So this should be the firewall public IP. Now when you try to deploy the firewall after you select virtual network, if you're getting an error, chances are there is no empty subnet. Remember, you must have an empty subnet called Azure Firewall subnet. Okay. So if it's not named such, you'll get an error message. Alright, so it takes about a good 5 minutes for the firewall to deploy. Now there's certain information we need, which is namely the private IP. Now the reason we need the private IP is so that we can deploy a user-defined route. So 10.01.4. That will be the next hop address for those user-defined routes. So here goes the route table. Alright, we're going to associate this user-defined route to the test firewall. Now, one of the things that may cause you to see a blank dropdown is your region. You have to make sure your firewall route, the route table, is in the same region as your virtual network. So if you put them in different virtual network, it will show up. Alright, so we want to apply this to the workload subnet. Now the route we're going to apply to the subnet is that all traffic that exits Okay, so once we apply this user-defined route against the subnet, any exit traffic out of the subnet will forward the traffic through the firewall. All right. So now the firewall gets to control whether or not to forward the traffic further. So the route we're creating is the default gateway to send it through virtual appliance, and this will apply to the workload subnet where this route table is associated. All right. Now we're going to switch over back to the firewall to start configuring some of these rules. All right. So we have application rules, network rules, and NAT rules. All right. So we're going to select application rule. All right. So here we're going to create a target rule. Okay, not a. This will be the target FQDN. All right. So this allows outgoing 80443 traffic with the destination of bing.com. All right. So when you go back to the application rule, I just want to highlight there are two sections. Okay. One uses FQDN tags. Now these are some of the most common Microsoft infrastructure services, such as HD Insight, Kubernetes services. So for example, all of my workstations needs to back up to Azure Backup. And I'll say, perhaps I should limit it to my subnet IP, but I'm not going to find out what that is. I'm just going to say star, wanting to go to Azure Backup or Windows Update. Okay, because these, we may not actually know what are the fully qualified domain name for these services are, and they might change over time. So with FQDN tags, it's much easier for us to create rules targeting these backend services from Azure. Now, if you know the specific domain, then you certainly can use target FQDN approach. Okay, so these help you set up rules. The next rule we're going to create is the DNS rule. Now this allows the DNS access to these two DNS servers. So any machines within that network is allowed to query those DNS on port 53. Alright, while the rule is creating, let's go to virtual machine and assign the server work, the DNS server that we have just allowed. So again, on the virtual machine, select networking, select network interface. Go to IP configuration. Alright, so sorry, not on the IP configuration, on the DNS server. And here is where we're going to specify which DNS server to use. And we're going to use those two IP addresses we created in the firewalls. Alright, so once this DNS setup is done, we're going to test it out by going to the jump box. So we have a SRV jump. Let's connect to it by RDP. Alright, so this is our jump box. We are going to use the jump box to get to the work VM. Okay. Alright, so this is going to navigate to the work VM. That's only accessible through the jump box. Now when you have the server manager up, click on local server and disable the IE enhanced security. Alright, so first we're going to test out the website rules, www.bing.com. Alright, so this works well. If you were trying to do any other website, you should get that message. Okay. There's no rule that matches the URL. Okay, so we know the application rule works. And the very fact that www.bing.com is able to resolve, as well as Google, that means the DNS outbound must be working. So this is the Azure Firewall in action. Alright, exit out the remote desktop. Clean up the resource group. Alright, this is lab number 7. We'll be working with network security groups and ASG. We're going to start by deploying a virtual network, create some application security groups, and create rules between these network objects. Alright, so we're going to have two groups of servers. Each one will be assigned to a different application security tag, if you will. So the server will be assigned either as web server or management server. Okay. Rather than hard coding based on IP address, we will define the rules based on the role these machine plays. We're going to create rules so that any machine designated as a management server, RDP, should be allowed. While any web server roles should have the IS web page accessible. All right. And we're also going to deploy a network security group to control the network access. Now we're going to start by creating a virtual network. So here's our VNet address, followed by, a default subnet of /24. We'll create our first application security group representing the web servers. The second application server group is going to represent the management servers. So now we have the two type of roles defined as an application security group. We can now go ahead and create an NSG that creates a rule between these roles. All right, so this creates the network security group. We want this network security group to be associated with the subnet we just created. So navigate to the NSG that was recently created, head over to subnet, and associate it. Alright, so this will be associated to the default subnet. NSG contains rules that applies to traffic. For instance, you may have a subnet with a node inside of the subnet. Now imagine that you have another server that tries to access services across the subnet. Okay. Now in this example here, we would have NSG on the outbound machine. So all the outbound security rules decides whether the traffic will even leave the machine. So there can be an NSG applied to the NIC. Now during a traffic heading to the green machine, the outbound security rules of the NIC applies first, followed by the outbound rule associated with the subnet, followed by the inbound rule of the destination subnet, and inbound rule of the NIC of the destination machine. Now consider if I have another server in the subnet. Now communication between these two machines are subject to the rules defined only at the NIC level. So communication between these two machines will not leave the subnet. So now the subnet NSG rule will apply to it. Alright, so keep that in mind. Depends on the path the traffic takes. The NSG bound at the NIC level or the subnet level controls whether the traffic goes through or not. When we define the rules, we can define a rule that based on source and destination. There are plenty of network tags that are used to represent different type of traffic. So for instance, I can hard-code an IP address. I can use a service tag that represents different types of Azure services. Okay, so perhaps I only want the storage account services to access or SQL Server from that region. So these are all service tag that translates to IP address. Earlier, we defined the application security group. So what that means is that we would like to control traffic based on the purpose of the server. So here, for web server, I want to ensure that port 80 and 443 will come through. Okay, because that's sort of the job of web server. All right, TCP. Okay, and we're going to say this should allow all web traffic. Oops, I think I got this reversed. Source is any. Sorry, it's the destination being the application security group. Got that reversed. Didn't look right. Alright, so there we go. Next, we're going to add one more inbound rules for the management server. Again, application security group. For the management server, we want to ensure RTP access is available. Allow. Now we have one NSG created, two application security groups, along with rules that controls the traffic flow to these destinations. So next we're going to create a couple virtual machines. Alright, so make sure this newly created VM will sit within the default subnet of the VNet that we created earlier. Alright, now we want to associate this machine to be part of the my NSG that we created earlier. We'll repeat this process to create the second VM for the management. Alright, when both machines are ready, we're going to start with the VM web. Let's go to the networking. Now we need to make sure that this machine is known as the web ASG. Within the application server group, this is assigned as a web server role. Alright, so here navigate to networking, application security groups. And this will be associated with the web. Now we're going to head over to the next machine. Alright, now let's head back to the virtual machine. If everything works correctly, the management server should have the RDP access open to it. Alright, so because it looks like we are getting into this VM, so we know the application security group associated with this machine has allowed traffic from the internet to enter the RDP. Now I'm returning to the web. We're going to install the web server. Alright, after a few minutes, the web server role should be installed. We can now go to overviews. As see the IS webpage comes up. Alright, so to recap, the reason this machine is able to expose ADM 443 is because the network security group associated has a rule so that these ports should be made open to the web server. Right. So that concludes the lab number 7. Application security group allows tags, allows rules to be created based on the purpose of these machines. Alright, so as we create more and more machines with the same ASG destination, they will all have the same port available automatically. Okay. Now in this lab, we're going to use Dockerfile to build a container image, have the container image hosted on the ACR, use AKS to pull the image and host both an internal nginx service and external nginx web services. Alright, so the first exercise, we are going to configure the ACR. Okay. Steps involved, this is all done through the bash, cloud bash. Okay, so here so this creates a resource group called AZ500 Lab 09 in East US. Okay, let's make sure the resource group is indeed created. This creates the ACR resource. Okay. All right. So you see that the ACR resource name is AZ500, and these are randomly generated numbers. Okay. Now when you use the AZ ACR list, it's going to say that admin user enable equal false. So that means our ACR will rely on Azure AD principles for login rather than an ACR username and password. Okay, so whoever wants to access to the images must authenticate through Azure AD to obtain an access token. So that means when AKS try to pull the image, AKS must be associated with a service principal. A service principal then obtains the access token to the ACR. Now, in this bash session, because this bash is started from the Azure portal, this bash handles our access token. So every interaction against the AZ-ACR, using the AZ-ACR command to interact behind the scenes submits our access token. All right. So here we create a very simple file, Docker file. It contains only one line from nginx. So we're just basically making a clone of the nginx container. This command here pulls up the ACR name that we've created earlier. Now the instruction says this builds an image. Actually, what this does is that it pack up the Docker file and everything in the local directory and creates an ACR build task. The ACR build task is one of the services provided by the Azure Container Registry. For a situation like this, we have Bash, and this Cloud Shell has minimal capabilities. So it's not capable of running Docker daemon to actually build a container. So instead, we can collect our source code, prepare a Docker file, and have the Azure Container Registry build the image for us. Save us the trouble of pulling image locally, build it, and then send it. So in one go, we're sending the source code to let ACR build it for us. All right. So it will echo back all the steps it took. But now these are happening here in the Cloud Shell. It's happening remotely. Now once that is done, we can navigate to the resource group and take a look at that. So here's the level 9. Here's container registry. Under repositories, okay, so the sample nginx is the name of the tag that we gave when we queued up that job. Okay. All right, so our tag is v1. So we should have one image v1 in the repository. Yep. All right. So this is the v1 and this is the manifest of the image. All right. Next, we're going to create a Kubernetes service. Alright, we're going to continue. Choose a node pool. We're going to disable scale set and disable virtual nodes. Alright, we'll have one node for our Kubernetes cluster. Alright, now it's important to observe that we will be creating a new service principal. Now, because this principal will be created for this Kubernetes cluster, this becomes the identity which external Azure services are interacted with will be from this service principal. So if we want to grant AKS permission, we got granted to this service principal. All right. Now, service principal will remain after you delete the Kubernetes cluster. If you choose the radio button system assigned manage identity, that means if you decide to delete this AKS, that identity will go away. All right. So we're going to create this default service principal. All right. And now we are going to enable our back services. All right. So let's take a look at the networking. All right. So we're going to go to advanced. Now, using the advanced, we're able to give each pod its own private address within the VNet. So this requires the container network integration for the CNI. Okay. Now make sure that DNS prefix, make sure you add your initial to it, so it will be globally unique. It will not conflict with any other service. going to turn off container monitoring from log analytics. All right. So the process of creating this AKS could be anywhere from a few minutes to 10-15. Alright, so the deployment is completed. Let's go back to the mesh. To communicate with a Kubernetes cluster, you must have credentials for it. And because we have already signed into the Azure using the Cloud Shell, we can download the credential to our cluster. And to make sure kubectl, which is the command to work with the Kubernetes, can give us our node status. Now earlier we had a service principal created for our AKS. So now our next command will attach our container registry so our Kubernetes cluster can access those images stored in the ACR. So notice AKS update attach ACR. So behind the scene, the service principal are given permissions to access the container registry images. Now specifically, the role, the RBAC role, is called ACR pull, okay, which allows the Kubernetes cluster the permission to pull image. We are able to create a job and upload image because we have ACR push, or at least the contributor permission. Okay, so both of those have the ability to push and create new image onto the ACR. Now keep in mind that attach ACR simply make our AKS a ACR pool, RBAC member. Alright, so let's just double check our ACR name. Now we're going to use this icon here to upload the 2 YAML file provided by the lab. So click on that, select upload. Now you'll find the 2 YAML file in lab 09. Alright, so we got the external file. We'll have to upload one file at a time, and here's the internal file. Alright, so both files are now available. And this YAML file defines a Kubernetes service. So let's take a quick look. Alright, so I'm going to open up the editor by clicking on this icon. And this is the external service. Now this external service defines a deployment by pulling an image from our ACR, and we need to update this so it uses our actual ACR name, which is this guy. Alright, so this will be the image path, okay, the container image. Now we will define an external load balancer service that will take port 80 and send into our container port 80. Alright, so let's go and save this. We're going to submit this YAML file so our Kubernetes can stand up the service. Because we asked for a load balancer service behind the scene, it will allocate a external public IP, but it will take some time. All right, so now the external IP has came up. All right, if the container has started up successfully, we should see the nginx welcome page. All right, so it may take a few minutes for the nginx to fully start. So take the public IP and refresh. After about 2-3 minutes, we get the welcome to nginx web page. All right. Now AKS can also deploy services that is only available within the cluster. So our next service that we want to deploy will be an internal service. All right, so let's take a look at the definition of the internal service. The deployment behaves exactly the same, so we need to deploy. Oops, just realized we forgot to replace that guy there. All right, so yep. So make sure you edit this to include the correct container registry. So there's that. Save. And then we need to send this command out again. Send this document to update our deployment. All right. So you'll see that deployment has been reconfigured to point to a different image, to point to a correct ACR. All right. All right. So this service is a service only available internally. Okay. So the annotation used to describe that the load balancer internal true. So the service we're requesting is internal facing. So there is no external access to the service. So next, we're going to drop into one of the pod and use that pod to access the internal IP of the service. So at the moment, there are two pods. One that is the external service, and one is the internal service. All right. So we're going to run a bash. All right, so we're going to have to copy that, paste it, and then we need to specify the pod name. So we're going to connect to this external pod. All right. Got to complete the command. All right. So the execute means I want to connect to I want the pod to execute a bin bash, and let me connect to it here. So once we run this command, we will enter the bash of that container pod. All right, and here we're going to do a curl to access the internal service. So this is the internal IP. All right, so there you go. So now we're accessing the internal IP for the nginx. All right. So this demonstration shows you that with an AKS, you can create services that's publicly accessible. Now, although they are publicly accessible, typically you may want an API management service to handle many of the security needs token verifications, HTTPS handling, and keep these nginx behind these type of API management gateway. Alright, so that concludes module 9, lab activity.